So this lesson is going to talk about angles, which you guys have some information about. However, it's also going to put them in context of a coordinate plane. So remember, our coordinate plane is basically us referring to having that X and Y axis. And we're going to talk about a standard way to draw angles on this coordinate plane. So if there wasn't a standard way, then when we said 90 degrees, we wouldn't know exactly which 90-degree position we're talking about. But because there is a standard way, we call this standard position in which we draw the angles, that means you always put what we call the initial side on the positive x-axis. That's going to be the starting point of all of our angles, and we're going to draw them going counterclockwise. So you're going to draw the terminal side of the angle where the angle would end. Okay? So for example, if I wanted to draw a 135-degree angle, I know that 135 degrees is 90 plus 45. So I would imagine that that would end somewhere here. That would be my terminal side of the angle, and the angle is drawn in standard position because the initial side starts where we're going to call that 0. And so this angle would be 135 degrees. So you can actually have this same initial side and terminal side using several different angles. So I called this 135 degrees. I'm going to draw a new angle in green. It's going to start the same place and it's going to end the same place, but I'm going to say this angle went a full lap around and then landed there. Notice that you see that spiral drawn there, indicating that it went a full lap around. We should know that a full lap, an entire circle, is 360 degrees. So this new angle that I drew in green is 360 degrees plus 135 degrees. It's a grand total of 495 degrees. These are technically two different angles. 495 degrees is much bigger than 135 degrees. But these angles are what we call coterminal angles because they share or have the same terminal side. Okay. Another thing that's important about this is that you can go in the opposite direction, but those are going to be negative angles. So I'm going to draw this same angle one more time, starting at this initial position, ending the terminal side in the same location, but I'm going to draw the arc here indicating that I went the other way. And now what that is I know that halfway around the circle is 180 degrees and an extra 45. So 180 plus 45 is 225. That's a negative 225 degrees. Negative 225, positive 135, and positive 495 would all be considered coterminal angles because they have the initial side and the same terminal side. Okay. So for our examples here, first we're going to sketch. So if we're going to sketch an angle in standard position, that's 100 degrees. We're going to give ourselves that coordinate plane. We're always going to plot our first mark on where that initial side will be, and I'm going to draw 100 degrees. So I know that 100 is a little more than 90, so that's just how we would want to draw that angle. Like this would be fine. For part B of this, the negative 215 degrees, again, I'm going to give myself a coordinate plane since I'm drawing the angle in standard position and my initial side. And I'll notice that this one's negative, so I know I want to go in the clockwise direction, and 215 degrees is, let's see, I know that this much is 180, and then I want to go how much more than 180? So 215 minus 180 leaves me with 35, an extra 35 degrees. So something like this could be a good representation of negative 215 degrees. In example 2, they've given us the pictures, and we are going to name the angles. So the first one, honestly, if they didn't mark any numbers on here and they just drew this picture, we would have to estimate. But they have marked something on here that says 3, 3, meaning they went over 3 and up 3 to get there. And in that case, we would know that that's a 45-degree angle because those are the same distances like a 45, 45, 90. If they didn't give you guys those numbers, you would just have to estimate something that's more than 0 and less than 90. For the second part here, for part B, I see the two sides and I notice it's gone this way. So I know the angle should be negative and it's gone exactly 3 quadrants, okay? So 3 quadrants, and a little reminder about these quadrants, you guys will need this. The quadrants go in the order of the angle. So 0 to 90 is quadrant 1, then 2, then 3, and then 4. So if you forgot the names of those quadrants, that will help you. This has gone 3 quadrants in the opposite direction, so it's going to be negative, and it's going to be 270 degrees because if I did 90 and another 90 and another 90, I would get 270 degrees. For example 3, it says which of the angles is not coterminal with the other 3. So here, I want to know which ones are coterminal. Now, a little hint about coterminal, I'm going to go back to our diagram here. Notice that we started with 135, and that ended up being the same as 495, and also as negative 225. And if you look at the number relationship here, if you add 360 to 135, that gave us 495. If we added 360 again, we'd get a new really large angle, but 855 would land in the same spot. Notice if you subtract 360 from 135, you actually get negative 225. So there's 2 ways for you guys to really determine these coterminal angles. You can draw them and count different things and figure it out, or you can really just add and subtract amounts of 360 and you'll end up with coterminal angles. So I'm going to look back at our example here, which is not coterminal with the others. So I'm just going to start with 30 because it's a nice small number. And think about if we added 360 to 30, some of the numbers that we might get. 390. So 390 is a coterminal angle with 30. If I add another 360, 750 is a coterminal angle. So 30 and 750 are coterminal. Now let's say I started taking things away from 30. Take away 360. So 30 minus 360 is a negative 330. So that's also coterminal with them. If I subtract another 360 degrees, I get negative 690. That's past 540. So negative 540 is the only one that didn't get the answer by adding or subtracting amounts of 360. So negative 540 is not coterminal with the others. You could have also drawn them to see what they look like and see that that one is not coterminal. So you should have a handout at this point. I tried to make sure that you were each provided with it of the unit circle. And the unit circle is something that we're going to use. It's kind of like if you were going to go on to calculus, it's kind of like learning your multiplication tables. There's some information from the unit circle you have to know really quickly. And so in general, it looks like this. And it looks really confusing. Today we're only filling in angles. And so what you want to do is you want to think about, we're going to break it down to make it simple. We want to think about our x and y axis going through this circle. So this would be our x axis here and our y axis here. And today all we learned about was angles in degrees. And so remember, we always started at our initial side, which was here. That makes this 0. And we know if we went a full time around the circle, it was 360. So landing at that position could be called both 0 and 360. And we know that each quadrant represents 90 degrees. So I'm going to start at 0 and go in the positive direction around the circle. And that would mean that up here on the y-axis is 90. Halfway around the circle is 180. If I add 90 more to that, I get 270 degrees. and then I get back around to 360. Then we know that if we cut 90 in half, we get 45. So these in here are 45s. Now, we could technically mark infinitely many, millions of different angles along this circle. Oh, I'm sorry, you guys, don't mark them all as 45. 45 in this second quadrant right here, we're not going to write 45. It's 45 more than 90, so it's going to be 135. And in this third quadrant, 45 more than 180 would be 225. And in this last quadrant, you're almost all the way to 360. You're just 45 away from it, and that number is 315. So these are the 45s. Now, you could say, how did I know that was 45? We only mark special angles on the unit circle. So it's like multiplication. Yeah, we know our multiplication tables, but we don't have everything memorized. Same with the unit circle. We're not going to learn about every angle. We're only going to learn about special angle. So a small reminder that the other special angles that you guys learned when you learned special right triangles in geometry were the 30 and 60 degree angles. So 30 degrees would be here. That's 30 degrees away from the axis. Its reflection is over here, and that means that this angle is 30 degrees before 180. So really the number we're going to label it with has to come from this here. Like we know this much is 30, but the way we number the angle in standard position is from 0 going this way. So if I did 180 minus 30, that tells me this is 150 degrees. And then we do the same things on the other sides. So going past 80 degrees, here 30 past 80 degrees is 210. And right here 30 degrees, almost all the way to 360, but stopping right here 30 degrees short is 330 degrees. And then the one last special angle we learned about is 60s. So going 60 degrees would land you here. And so the mirror image of that is here, where this is 60 degrees. But remember, we're not labeling it as 60. We're labeling it as what is this number from 0 that lands us at that position that's 60 degrees away from the x-axis. So 60 degrees before 180 is 120. And then 60 degrees after 180 is 240. And 60 degrees all the way around, but stopping 60 degrees before 360 is 300 degrees. So for now, that's all I want you guys to label on here. We're going to come back and label these with some other ways to measure them and some coordinates, since it is on a coordinate plane at a different time. So you want to save this paper. But right now, we just wanted to get used to these special angles around the circle.